All right, so Algebra Unit 6, radical stuff, going to be doing all of this. And, and I highly recommend checking out some Algebra 2 regions problems, especially this problem, problem 22. This problem is basically a trick question from the Algebra 2 regions, and I do this problem at 1915. So I highly recommend checking out that video, especially this problem, because this problem is very tricky. Now let's get started. All right. For all positive values of x, which expression is equivalent to whatever this is? What you have to realize is that you can write square roots or radicals, and you can turn them into exponents. So whenever you have, let's say, x to the nth power, and it's to the, let's say, mth root, this is going to be equal to x to the n over n. So for example, for this radical right over here, I can rewrite this as x to the 11 over 4. Because guess what, right? This n right over here represents the power, and the power goes on the numerator, right? And at the bottom, we have our n, which is the thing on the outside, and the thing on the outside goes on the denominator. So that's going to be what we have here. Now for the square root of x, we can rewrite this as x to the 1/2 power. You can think about the square root of x as the second root of x. So technically, what we have over here is the x to the first power, and it's to the second root. So we're going to have x to the 1/2 power. And remember, we're multiplying these two things together. And if you remember your exponent properties, you'll realize that if you multiply two things with the same base, you can just add up their exponents. So all of this is going to be equal to x to the 1/2 plus 11 over 4, right? So for your exponent properties, we keep the base, but we add up the exponents. So in this case, 1/2 plus 11 over 4, I can rewrite 1/2 as 2 over 4, so we have a common denominator. So 2 over 4 plus 11 over 4 is x to the 13 over 4. And that's going to be our answer. Now, if you're unsure, if you're really unsure about this answer, graph it out. So I'm just going to be using Desmos, but you have a TI-84 for your Algebra 2 exam. So you can use that. You can press y equals, and then what you can do is, first of all, you graph out what you have originally. So originally, we have the square root of x times the fourth root of x to 11. So that's what we had originally, the square root of x times, let's scroll all the way down here. So the fourth root of x to the 11th. So this is what we had originally. Now, theoretically, if my answer is the same thing, right, because I'm trying to find out which expression is equivalent to this, right? So if my expression for x to the 13 over 4 is equivalent to what I have originally, then theoretically the graphs of these two functions should also look the same, right? So I'm going to graph out x to the 13 over 4. And look, when you look at that, they have the same graph, meaning that they're equivalent, okay? So even if you don't know the problems, just graph all of these functions out. See which graph matches out with what you have originally, and you still get the correct answer. With guarantee, by the way, because, graphing calculators, unless they're glitched or something, they're probably going to be correct. Okay. Jin solved by squaring both sides while extraneous solution he found. So he squared both sides. So he squared both sides of this equation. Now what you have to realize is that when you square a square root, it's going to cancel out, right? If you have a square root of 2, and let's say you square this, you're going to get just 2, okay? So the important thing to know is that if you have the square root of x and you square this, the square root and this to the second power cancels out, so you just get x, okay? And kind of the reason why that works is, you can think about the square root of x as x to the 1/2 power, like what we said before, right? We said how x, the square root of x is x to the 1/2 power. So imagine if I square x to the 1/2 power. You can remember from your exponent properties that if you have x to the some power, and it's so we have x to the some power, and then in parentheses it's raised to another power, you just multiply out the powers together. So in this case, I have x to the 1/2 power to the second power. I just multiply the exponents together, so I just get x to the 2 times 1/2 is just 1, and x to the 1 is just equal to x. So, yields the same result. All right. So basically, this problem is asking us which extraneous solution did he find? So extraneous solutions are basically fake solutions. They're solutions that do not work, all right? And they're found very commonly in square root equations, like ones, in this problem. Now, extraneous solutions, they come from solving the problem. So, let's say you solve whatever the square root equation is, you get x is equal to, let's say, I don't know, some value, and x is equal to another value. Well, sometimes, the answers can be fake, and those fake answers are called extraneous solutions. Okay, so let's get to it. So if I square the square root and the square root of 4 minus x, and I square this, the square root and this square is just going to cancel out. So I'm just going to get 4 minus x. And then now I have x plus 8 squared, quantity squared. So I'm just going to have to distribute all of that out. So I get x squared plus 16x plus 64. Let's just bring everything to one side. So I'm going to subtract 4 from both sides, and I'm going to add x to both sides to make one side equal to 0. So I'm going to have 0 is equal to x squared plus 17x plus 60. Now, is there a way I can factor this? And I mean, if you don't know if you can factor this or not, you can always use the quadratic formula, of course, but you can also use your TI-84. What you do is you put your last term or your constant in for x. So you put 60 and you divide it by x. You're going to go to table, and it's going to give you all the factors for it. So two numbers that multiply out to be 60 and add up to be 17 are 5 and 12. Okay, so TI-84 is pretty powerful, let's just say. So x plus 12, x plus 5, you get equals to 0. So either x is equal to negative 12 or x is equal to negative 5. Now let's see if these solutions work. So let's say if I plug in negative 12 into my original equation. And keep in mind, my original equation was the square root of 4 minus x equals x plus 8. So let's see what happens when I plug in negative 12. I get 4 minus negative 12, which is just 4 minus negative 12, which is just 4 plus 12. 4 plus 12. And this is going to be equal to negative 12 plus 8. So then I get the square root of 16, which is 4, is equal to negative 4. 4 isn't equal to negative 4, so x is equal to negative 12 is an extraneous solution. So I get answer choice number 2. Now you can also check the other solution, right? X is equal to negative 5. Let's see if this one is an extraneous solution. So if I plug in negative 5 into this, I get the square root of 4 minus negative 5, which is 4 plus 5, which is 9, is equal to negative 5 plus 8. Negative 5 plus 8 is just equal to 3. The square root of 9 is equal to 3, which means negative 5 works. All right. Let's see. Solve algebraically for this. All right. Solve algebraically for x. Now, how do I do this? I want to get a common denominator. So how can I get a common denominator? Well, what I'm going to do is first of all, let's do this. What can x be equal to? If I have 1 over 2x minus 5 over 6 equals 3 over x, what can x be equal to? Well, x can't be equal to 0, because if I plug in 0 in for x, I'm going to have 0 as my denominator, and I can't divide by 0, so x cannot be equal to 0. Okay, that's something known as a restriction. Basically, what your x cannot be equal to. All right, so 1 over 2x. Let's do this. Let's multiply the top and the bottom of this equation by 3. Let's multiply the top and bottom of this part of the equation by x. And let's multiply the top and the bottom of this part of the equation by 6. You'll see why I do this. So 1 times 3 is just 3. And then 3 times 2x is 6x. And I have 5 times x, which is 5x, divided by 6x. And I have 3 times 6, which is 18. And I have 6 times x, which is 6x. And now notice how I have a common denominator. So this is why I did this strategy. It's because I wanted to get a common denominator, and I instantly saw that I have a 6 as my sort of highest thing, and I have an x. So how can I get 6x as my common denominator? Well, if I multiply this one by 3 on the top and the bottom, I multiply this one by x on the top and the bottom, multiply this one by 6, top and the bottom, I'll get 6x as my denominator. So what I'm going to do now is I can combine these two terms because they have the same denominator. So I can combine this into 3 minus 5x divided by 6x is equal to 18 over 6x. All right, now here's an important thing to know. So basically, like, for example, let's say if I had 3 divided by 6x. Let's say if I was solving a different problem. Let's say if I have 3 divided by 6x minus 5x plus 1 over 6x equals 18 over 6x. And I wanted to combine this into one fraction. How would you combine it? Remember, this is 3 minus this whole thing. Okay, this is 3 minus 5x plus 1. So if I wanted to combine this into one fraction, what I actually have to do is I have to put parentheses over 5x plus 1 so that I distribute this negative sign to both terms. A lot of people, what they don't do is they just they don't put any parentheses so that they're only making this negative 5x, but they don't make this 1 negative. All right, because what we have originally is 3 over 6x minus 5x plus 1. So it's minus this whole entire numerator. So make sure when you combine it into this fraction, it's also. But for our problem, we're lucky enough to have only one term in the numerator. Right? We're lucky enough to have only one term in the numerator, so we don't have to worry about that. But that's just something, just know. We can cross multiply. So we get 6x times 18, that's going to be 108x. 6x times 3 is 18x. And then 6x times negative 5x is negative 30x squared. If I move everything to one side, I'm going to get 30x squared, subtract 18x to both sides, so I get plus 90x is equal to 0. Now let me factor out a 30x, because both these terms have 30x in them. So 30x, and this is x plus 3, is equal to 0. So either x is equal to 0, or x is equal to negative 3. However, the thing is, remember in the beginning of the problem, we said how x can't be equal to 0. So, because our denominator would be equal to 0. So this is actually an extraneous solution. If one of the solutions, or it can be both, but if one of the solutions matches up with your restriction, well, then it's an extraneous solution, right? Because if it meets the restriction, right, that x can't be equal to 0, right, but you get x is equal to 0, then, obviously can't be a solution. And let's just check our answer with x is equal to negative 3 to ensure that we get the correct answer. So I have 1 over negative 3 times 2, which is negative 6, minus 5 over 6 is equal to 3 over negative 3. Now, negative 1 over 6 minus 5 over 6 is just negative 1, and negative 3 over negative 3 is just negative 3. So get negative 1 is equal to negative 1, which is true, meaning that we have the correct answer. And of course, once again, it says solve algebraically, meaning that we have to show all of this work, but you can once again check the answer with a graphing calculator. So minus 5 over 6, and then this is going to be equal to 3 over x. And notice how it has an intersection point at x is equal to negative 3, meaning that we have the correct answer. Okay. So, all right, this one you just have to use your rational exponent properties. So once again, in order to convert from radical to exponents, well, what we do is we can rewrite it as a to the 10 over 5th power, right? Because remember, the thing inside the root goes on top, the thing outside the root goes on the bottom. You can kind of think about it like that. And 10 over 5 is equal to 2. So this is right over here is equal to a to the 2nd power. Now, I have a to the 3rd power to the 1/2 power. So I just multiply out the exponents. So on my denominator, I have a to the 3 over 2 power. Okay? I have a to over 2 power. All right, now what I'm going to do is, since I have a to some power divided by a to some power, because I have the same base, what I do is I just subtract the exponents. This is going to be equal to a to the m minus n power. So in this case, this is going to be equal to a to the 2 minus 3 over 2 power. And 2 minus 3 over 2 is just a to the 1/2 power. Okay? Now, the thing is, we need to know, we need to read the problem. Given a is greater than 1, use the property of rational exponents to determine the value of x. And we see that x represents the exponent for a. So in this case, x is equal to 1/2. So make sure you're reading the problem. It was my fault that I didn't really read the problem. So, but make sure, they try to trick you up a lot with these, determine the value of x and then, all of that. All right, now this is just solving exponent problems without using logarithms. Basically, what you have to notice here is that, first of all, you can obviously just graph out these two functions. But another way to do this is you can realize that 5 to the 3rd power is equal to 125. So what I can do is I can turn this 125 into 5 to the 3rd power, and then this is to the x minus 2 power. All right, so all of this is to the x minus 2 power. Now remember that, you have an exponent to an exponent, so you just multiply them out together. So this is just going to be equal to 5 to the 3x minus 6. because, you distribute the 3 to both terms, right? Because you're multiplying them. And this is going to be equal to 5 to the 2x plus 1. Now, because the bases of my exponents are the same, I know that the powers have to be equal as well. So I can just set the powers equal to each other. 2x plus 1 is equal to 3x minus 6. Kind of makes logical sense, right? If bases are equal, exponents have to be equal as well. So if I subtract, actually, I can subtract 2x from this side, so I just get x is equal to 7. That's going to be our answer. Now, let's see if this is actually true, so we can once again check our answer with our graphing calculator. So we have 5 to the 2x plus 1, 2x plus 1, and then we have 125 to the x minus 2. Notice how it does have an intersection point. So let me actually, I have to really zoom out for this, but shoot, okay. We got x is equal to 7, but the problem is that this function is a little too high. Yeah, the function gets a little too crazy at x is equal to 7. Can't even see it. But I mean, instead of checking our work graphically, let's actually just plug it in and see what we get. My bad. It's a little, numbers get a little too big. So if I plug in 7 here, I get 5 to the 2 times 7 is 14, and 14 plus 1 is 15. So I get 5 to the 15. Now for this side of the equation, if I plug in 7, I get 3 times 7, which is 21, and 21 minus 6 is 15. So I also get 5 to the 15, meaning that this is going to be our answer, right? Because it's equal to each other. All right, determine this algebraically. And before we do that, let's just do this quick problem. What's this going to be equal to? Well, let's convert it into exponents first. So I can rewrite this as 5 to the 1/3 power. I can rewrite this as 25 to the 1/3 power. All right. Now, what I can do is I can rewrite 25 as 5 to the 2nd power to the 1/3 power, right? Because 25 is 5 to the 2nd power, right? And this is going to be multiplied by 5 to the 1/3 power. So remember, power to power in this parentheses form, multiply the exponents. So this is going to be equal to 5 to the 2/3 power. Same base. So what you do is you add up the exponents when you're multiplying these two things together. So you're just going to have 5 to the 1/3 plus 2/3, which is just 1. All right. All right. Determine this algebraically. Okay. Once again, you can just graph this, but let's just do this the normal way. And keep in mind that, let's say if you were given a problem like the square root of 3x plus 7 plus 1, so this plus 1 is outside the square root, and let's say this is equal to x. For this problem, you would not square both sides immediately, because what you're going to do is you're going to end up having to do FOIL for these two terms, and you're going to end up with another square root. So that's not going to be good. What you want to do is you want to first isolate the square root, make sure the square root is on one side, so that now you can just square both sides. You can just square both sides, and now you don't have to deal with FOIL on this side. You have to deal with FOIL on the right side, but you don't have to deal with the annoying radical side. Okay, but luckily for us, for this problem, they already kind of isolated the square root for us, but just important to know. So we're going to have 3x plus 7 is equal to x squared minus 2x plus 1. We're going to have x squared minus 5x, minus 6 is equal to 0. You can factor this out to x minus 3 times x minus 2, and then you're either going to get x is equal to 3 or x is equal to 2. Now, we have to check our work once again. Whenever you're doing these square root problems, you got to make sure that, you don't get a fake solution. So let's plug in 2 in for x. So I get 3 times 2 plus 7. Square root of this is equal to 2 minus 1. So this is equal to 1. And I get, Yep. Wait, no. No, I did this wrong. My bad. All right, so yeah, two numbers that multiply out to be -6 and add up to be -5 are x minus 6 and x plus 1. Sorry guys, is equal to 0. I was like, what? Both these solutions don't work? That's kind of crazy. All right, x is equal to 6 or x is equal to -1. This looks better. Okay, so now if I plug in -6 in for x, I get the square root of 3 times 6 plus 7 is equal to let's see, 6 minus 1. All right, so I get 3 times 6 plus 7, which is 25. The square root of 25 is equal to 5. So yeah, because this is the square root of 25, which is equal to 5, and 5 is equal to 5. This is correct. Let's plug in -1. So if I plug in -1, I get 3 times -1 plus 7 is equal to -1 minus 1. So so this side is going to be -2. And I know that the square root of a number can't yield a negative result, right? A square root of a number is always going to be positive. It can never be negative. Square root of a number is greater than 0, greater or equal to 0. It can't be negative, right? So immediately I know that -1 is an extraneous solution. This has to be our answer. Once again, we can do our thing. And 6, 5. Yep, there's no answer at whatever -1 there is. That's a fake solution. All right. Given the inverse function which function represents f of x? How do we do this? Well, what is an inverse function in the first place? If I have a function f of x, right, it's going to have x and y values. So let's say when x is equal to 1, y is equal to 0. When x is equal to 2, y is equal to 1, x is equal to 3, y is equal to 2. Well, an inverse function, which is represented by this -1 up top, it basically swaps the x and the y values. So now when x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 2, and so on. Right? So you see the pattern. It's basically same function, except the x and y values are flipped. And actually, it can go both ways. You can actually set this function right over here to be your original function, and this function right over here to be your inverse function. And notice how it still works out perfectly, right? It's this sort of closed loop that you have. All right, so you can set this one to be the inverse and this one to be the original, or you can set this one to be the original and this one to be the inverse. So given the inverse function f inverse, which function represents f of x? So if we're given an inverse function and we're trying to find the original function, well, another way we can interpret that is if we're given a function f of x, well, which function represents the inverse of this function, right? Because we know that this inverse function can go both ways. So it doesn't matter like if we're trying to solve for inverse or if we're trying to solve for original, but we're still going to get the same result either way, right? As seen in this loop, right? So which function represents the inverse of this function? So we have, in this case, we have y is equal to 3 over 2x plus 1 over 6. To find the inverse of a function, you're going to swap the x and the y values. So you're going to swap the x and the y values. So this x right over here becomes a y, and this y right over here becomes x. And what you're going to have to do is you're going to have to solve for y. So in this case, what I'm going to do is I'm going to subtract 1/6 from both sides. So I get x minus 1/6 is equal to 2 over thirds y. I can just multiply both sides by 3 over 2. I can just multiply both sides by 3 over 2, right? Because 3 over 2 times 2 over 3 cancels out, so I just get y is equal to, let's distribute this 3 over 2. So I get 3 over 2x, and this is going to be minus 3 over 12, which is just going to be 1/4. And that's going to be my inverse function. So let's see, okay, this one. That's going to be my answer. Let's actually do another inverse problem. Let's say if I have f of x is equal to 5x plus 6 divided by 2x plus 3. And let's say if I want to find out the inverse of this function. Remember what we do. Your first step is to be swapping the x and the y values. So all the x's become the y's. So all x's become y's. So I get 5x plus 6 divided by 2y plus 3. And all the y's become an x. So f of x is the same thing as y, basically. So all the y's become an x. Now let's just solve for y. So I'm going to multiply both sides. I'm just going to cross multiply, I guess, right? Because you can think about this x as x over 1, so let's just cross multiply. So I'm going to get 2yx plus 3x, right? Because I have to distribute this x to both terms, is equal to 5y plus 6. Now what I'm going to do to solve for y is I'm going to move all the y's to one side and all the non-y's to the other side. So it's going to be 2yx minus 5y is equal to negative 3x plus 6, right? So I just moved all the non-y's to one side, all the y's to one side. The reason I do this is because now I can factor out a y. And now you can clearly see where I'm going. I divide both sides by 2x minus 5. So I get y is equal to this. Or you can also think about it as my inverse function is going to be equal to this. That's going to be the answer. One more thing about inverse functions is that let's actually graph out these two functions that I've plotted out. So I have y is equal to 5x plus 6, and this is going to be divided by 2x plus 3. That's one function I got. And then my inverse function was negative 3x plus 6, negative 3x plus 6, and then I divided by 2x minus 5. 2x minus 5. And I want you to notice something. Whoa, these two functions look pretty similar. And actually, inverse functions are literally the exact same functions. I mean, this, if I call this one f of x, actually, so if I have a function f of x, well, the inverse of f of x is going to be literally the same graph as the original function, except I've reflected about y is equal to x. So imagine if I took this red graph and I flipped it around from y is equal to x, right? And then, then I would get my inverse function. So that's how you can connect inverse functions graphically with one another. So, if you want to check your answer for if you got like an inverse problem correct, well, one thing you can do is just graph it out and see if it reflects properly about y is equal to x. All right, now let's move on to systems of linear equations. Okay, and I actually have a system of linear equations trick I will show you guys at the end of the video. So stay tuned for that. Now to solve this 3-variable system of linear equations, because I believe in you guys that you can solve 2-variable system of linear equations, is from a 3 system of linear equations, you can actually create 2 system of linear equations, 2-variable system of linear equations. What do I mean by that? Well, let's add these 2 equations together. So if I add these 2 equations together, I'm going to get 2x minus y. The z's cancel out. So then you have 2 plus negative 4. So it's going to be equal to negative 2. So that's my first kind of mini equation. Now what I'm going to do is I'm going to add the last 2 equations together. So these 2 x's form 2x. These 2 added together form minus 11y. These z's cancel out. And then this plus this gives me negative 22. And notice how I get a 2-variable system linear equation from a 3 system linear equations. So yeah, the first step for solving 3-variable system linear equations is making sure that you're able to create 2-variable system linear equations from it by canceling out a term. So in this case, right, the term that I basically canceled out was this z, and I did it by adding up these 2, and then I did it by adding up these 2. Okay. Now what I'm going to do is I can just solve this 2 system of linear equations by subtracting, because these 2 x's cancel out. Negative y minus this is going to be that's going to be 10y, I'm pretty sure, right? Because negative cancels out, so I just get negative y plus 11y, which is 10y, and negative 2 minus negative 22, negative makes it positive, so I just get 20. So that means y is equal to 2. Now immediately, wait, whoa, what the hell? What is the solution for the system of linear equations below? There's 3 variables to this system of linear equations, meaning that there has to be kind of 3 values, right? There has to be 3 values for it. And you can immediately see how, right, it can't be answer choice number 2, because our answer choice number 2 is saying that our x value is equal to negative 2, our y value is equal to negative 2, and our z value is equal to 6. But our y value we said is equal to 2. So that can't be the answer. So we only have 1, 3, and 4 left. And notice how in all of them our y value is 2. So that kind of checks out. All right. Now let's plug in y is equal to 2 back into one of these mini equations. So I get 2x minus 2 is equal to negative 2, and I get 2x is equal to 0, so x has to be equal to 0. And from this, I can see that number 1 can't be the answer, so it's only 3 and 4. Now what I'm going to do is I'm going to take y is equal to 2, x is equal to 0, and now I'm going to plug it back into the big equation. So you can kind of see where I'm going. So I know x is equal to 0, I know y is equal to 2, so I'll just get 2 plus z is equal to 2, which means that z has to be equal to 0 as well. And that means that number 3 is our answer, right? We have 0, 2, 0, which is 0, 2, 0 there. All right. Now, finally, we have one more. Oh, my goodness. This is a pretty long video. The solution set of this is what? So once again, I'm going to find, I could obviously graph this out, but in order to do this problem, let's just multiply for this part of the equation. Let's just multiply the top and the bottom of this equation by x plus 2. For this part of the equation, let's just multiply the top and the bottom of this equation by x minus 5. Because now I have a common denominator of x minus 5 times x plus 2, right? X minus 5, x plus 2. So whenever you're doing these rational equation problems, so rational equation basically just means you have a polynomial divided by a polynomial, right? So in this case, this would be kind of a rational expression if it was just by itself, because I have a polynomial divided by a polynomial, right? And whenever you're solving these problems, the common denominator is usually just going to be the two denominators multiplied out together, right? And they literally kind of give us a hint about what the common denominator is from this big thing. So let's do this. So I have x minus 5 times 6, so that's going to be 6x minus 30. And it's going to be divided by our common denominator, which is x minus 5 times x plus 2. X minus 5 times x plus 2. And this is going to be equal to this. I'm too lazy to write it out, but, you know. All right, and then I have x plus 2 times x plus 3, so that's going to be x squared plus 5x plus 6. So this is going to be divided by x plus 2 times x minus 5. And because they have a common denominator, what we can do is we can just combine these two things together. So I have x squared plus 5x plus 6. And then this is going to be plus 6x minus 30 is equal to, and then whatever that is. Okay, so I have x squared plus 11x, and then minus 24, and then don't forget it's divided by this denominator, and it's going to be equal to this. Now, first of all, what can x be equal to? So I probably should have said this earlier, but what can x be equal to? X cannot be equal to negative. X can't be equal to 5, right? Because if you plug in 5 here, your denominator is 0. X can't be equal to negative 2, because if you plug in negative 2, well, you're going to get 0. So immediately I can eliminate answer choice number 2 because it has a 5 in there. And also answer choice number 3 because it also has a 5 in there, right? It's saying that answer choice number 3 is saying that x can either be 6 or 5. Well, you know, x can't be equal to 5. So we already have a 50-50. So I'm feeling good about this. Now, let's see what we can do. I mean, well, if I got a common denominator, and so let me just kind of just bring this thing down. So take a look at this. If I have a common denominator, that means that my numerators have to be equal to each other as well, if my denominators are equal to each other. So I'm going to have x plus 11x minus 24 is equal to 6 plus 10x, right? And now I can solve this. So x squared plus x minus 30 is equal to 0. So we have x plus 6 times x minus 5. So either x is equal to 5 or x is equal to negative 6, right? So that means that number 1 has to be our answer because you know, x can't be equal to 5 because we said that was an extraneous solution, right? X can't be equal to 5 and it can't be equal to negative 2. So that's an extraneous solution, meaning the only solution that works is x is equal to negative 6, and you can graph this out. So you can graph this out. So my original equation was x plus 3 divided by x minus 5 plus 6 divided by x plus 2, and this is going to be equal to 6 plus 10x, and then this is divided by x minus 5 times x minus 2, x plus 2. And notice how they have an intersection point at x is equal to negative 6. So this checks out. Okay, and they don't have a solution at x is equal to 5. At x is equal to 5, it's a vertical asymptote. All right, so yeah, that's going to be our answer. All right, so it's kind of like one last thing I want to talk about. So, you know, when I was solving this problem, where, you know, I took all of these values right over here and I sort of ignored the denominator because, you know, I knew that if these two things were equal to each other, so if in this case x squared plus 11x minus 24 divided by x minus 5 times x plus 2, I know that if that's equal to 6 plus 10x divided by the same denominator, well, if the denominators are equal to each other, well, the numerators have to be equal to each other as well. And I set them equal to each other. However, in this problem right over here, I don't actually think you can do this strategy. So whenever you have only a single x term in the denominator, I don't think you can do that strategy because you're going to be missing out on a solution. I'm pretty sure that that's how it goes. Feel free in the comments to tell me if I'm wrong. But I mean, when I solved this problem, I got that x was equal. When I solved this problem, what did I get when I solved this problem? I got that x is either equal to 0 or x is equal to -3. And it just so happens that x can't be equal to 0. But if I were to set the numerators equal to each other and I solved this equation, I would have gone only x is equal to 3. But I wouldn't have gone the second extraneous solution. And this extraneous solution is important because if the problem asks you, what extraneous solution did you get when solving this problem? Well, if you did it, this way, where you only set the numerators equal to each other, you wouldn't have gone the extraneous solution. So make sure if there's only like a single x term and there's like x term in the numerator and you multiply them out to get x squared, that's where the extraneous solution happens. So, just be mindful of that.